Why Eve and why now? It's pretty simple. We need it. The reason is the world has changed. In the past, we mostly debated whether or not the Earth was warming, if humans were responsible. Did it matter? Could we do something about it? Today, we know the Earth is warming. We know we have to do something about it, but we don't really know what, at least not at the level of detail that's needed to empower local action to adapt to the changes, to reduce vulnerabilities, to increase resilience, or to best plan mitigation activities that will, on the long run, reduce the warming or minimize the harm that the warming will cause. Eve responds to this change in the basic needs of society as we grapple with the problem of human-induced climate change. But the funny thing is, and maybe you've heard this old quote, there's never a question that isn't pregnant with its own solution. And it's not so different with Eve. It could be that the only reason we're posing this question is because we see at the same time our ability to answer it. And that's due to amazing changes in technology. We now have computers that allow us to calculate how the climate system behaves in ways that were unimaginable in the past. And we see the development of artificial intelligence and generative AI that allows us to process and interact with amounts of data that previously was inconceivable. So on the one hand, we can create synthetic futures through computing, and on the other hand, we can interpret what they mean, and we can do that all on a scale that fills this imagination deficit that society is facing as it marches forward into an ever-warming world. So let me take a bit of a deeper dive into computing and explain how this is shaping what we can imagine doing in the future. So when you look at the computing problem for climate, you can imagine a graph in your head where the y-axis describes how many ensembles you could compute on a given machine with a throughput of 1 simulated year per day. And the x-axis would be the scale or the grid scale of a global computation. On that graph, if you have a given machine, let's say the most powerful machine in the world, you would get a diagonal line that would go from the upper left to the lower right. And it tells you that you could simulate millions of ensemble members on that machine with a coarse grid, or very few ensemble members on a very fine grid. Above and to the right of that line, we can't compute, and below and to the left of the line, we can. It's all fine, but the type of calculations we do for climate make another line, and that's the strong scaling limit. And that's really the throughput you can get from any single simulation on a machine. And that curve is flatter than the machine curve. And what it means in a practical sense is, unless you want to compute millions of ensemble members, that your ability to use a really big machine in its entirety can only be expressed if you simulate on the bottom right side of that graph, which means simulating a relatively small number of ensemble members at the finest possible scale. As you move to coarser scales, you might want 100 ensemble members, and you could do that on 1% of the machine, but why would you want to use the world's biggest machine to do something that only needs 1% of that machine, or 0.1% of that machine? So if we want to use the biggest machines possible, the question they pose is, would it be useful if we could simulate the Earth at 1 kilometer scale globally with a few ensemble members for a few decades? And the answer is yes, most definitely. In fact, that's exactly what we need. But we won't be able to do it unless we work together to find a way to evolve our models to take advantage of this enormous capacity. The other part of the problem was AI. And for a long time, when I've worked at the frontiers of resolution, the problem has often been less about the computing and more about the analysis. Because you create enormous amounts of data, you put it to disk. You've written it to disk in ways that are formatted to help you write it. And then you confront yourself with the problem of reading it and processing it and storing it. And that's where AI really struck a number of us for its capacity to extract information from enormous amounts of data, which bring the data to life and allow people to interact with it. So what does all this mean for Eve? That was actually the question we posed leading academics, scientists, service providers, policymakers, who came to Berlin in July of 2023 to discuss this question. It quickly became clear that in this new era, we need new institutions that respond to the new needs. So think about it. The way climate science has grown up was that we developed models to answer or resolve knowledge disputes. Is the world warming? Are humans responsible? Can we do something about it? These sorts of questions. And a byproduct of this activity were things that were useful to society. And a whole community of creative and ingenious and original people found ways to use these, let's call them byproducts of the knowledge industry, to begin trying to inform society. But what we recognized in Berlin is that's exactly what we need. We need a reliable way that responds directly to that need. It doesn't kind of collect the byproducts of a knowledge industry, but it's a service industry explicitly constructed to respond to the information needs of users. So that's the flip. Climate science has matured and the world has evolved to a point that we need new institutions to meet the needs of society. Out of that realization, we began articulating principles that Eve would have to follow to address that need. One principle, even if it wasn't articulated exactly like that, but which was crystal clear, was that this is a global problem and we need to work on it together. Eve has to be an international effort, a cooperative international effort that responds to the societal need for information based on the best possible science and the most advanced technologies. You can't think about Eve as just providing better information with finer granularity based on better science. If you do that, you won't solve the problem. At the same time, you need to figure out ways that if you provide that information, that people will also be able to use it. And that was another guiding thread of the discussion, you could call it a principle, which flavored the structural elements that we thought Eve should incorporate. So here we are in Berlin. We have this idea that Eve will only be successful if it's constituted as an international cooperation that responds to users. And it should involve certain structural elements. And what are those? One is, if we want to provide the information at the scale that's useful to people and with the fidelity that it would be reliable, we need to access the technology. If we want people to use the data and bring their own data as a complement, push the information generation even further, they need to feel ownership of the activity and they need to be part of it. So how to engage the communities who would use the data in the production of the data? There was another element to this, is that for all of those things to work, you needed to make the information interactive. You needed to enable interactivity. Unless you gave people the chance to kind of virtualize what the science was providing, the best available science, all these other things probably would fail. So imagine that you could just, conjure up what the world would look like for you, right there at your fingertips, in the language that you're used to, not a scientific language, not a report that's been filtered through all sorts of different policy levels, but which virtualizes it for you in your own terms so that it's useful for you. The other aspect was in many places where the information is most needed, the capacity to participate in the production development and the use of the data is underdeveloped. So how do you take advantage of that enormous human potential? So how could this work? We realized pretty quickly that EVE should be based on a federation of centers of excellence, each of which was a multinational, international cooperation, and where the federated centers cooperated with one another. Each of these centers of excellence should be tasked with using the best available science to fill a data space with these global projections of future climate expressing local granularity. That would be the data floor, so to speak. And by having multiple centers of excellence, you could explore more scenarios. You could use a larger group of models to address uncertainty, and you could engage more people. The second point encompasses multiple elements, but it's really to enable equitable access to the data we create in this layer. The idea here wasn't that the data layer, we called it a digital commons. And the idea wasn't that this data layer would be just something where we distribute the data to people who need it, but it would be a playground, or if you like, a digital dimension where people meet and learn how to use the data to address their information needs. For some communities, this capacity is fairly well developed, and you could imagine private companies, consulting firms, startups coming there, identifying a niche need for the data, building apps and building applications that fulfill that need, selling the data, and so on. Fine. But there's other communities who wouldn't be seen as markets, but have a strong need for that data. So we need a robust public participation in that. So we need to create space where if you're a small country without a lot of resources, you could actually go into the digital commons, find the resources you need to analyze the data, develop capacity for doing that. Or we could use this existing infrastructure, how to invite and mobilize and engage this existing and growing network and infrastructure of climate services, how to enable them to more effectively use the information in this data layer to meet the existing needs of their users. So this open and equitable access is really a key element of each of EVE's centers of excellence. A third element was really coming back to this point of capacity development. And that is how to create structured programs in each center of excellence so that they reach out to countries where this capacity is underdeveloped and help develop the capacity so that people in those countries can actually be engaged in the production of the data, not just in the use of the data. And this was seen as a way to get around this common problem that we have, that if people aren't involved in producing the information, then it will be hard for them to see how it might be useful to them. EVE means for scientists, of course it means that there's more interest in our field, more people come to the field because they see career paths and training opportunities, and so it raises the stature of the field as a whole and our ability to access talent. I mean, that's obvious, but more profoundly what it does is it identifies the knowledge gaps that we need to fill scientifically. And it gives us the tools to fill those gaps. Because by cooperating around infrastructure that is on a scale that none of us individually or nationally or within our labs could manage on our own, it allows us to see worlds that we couldn't see otherwise. It's kind of amazing when you look at many, many fields of science, they have access to shared infrastructure that we don't have in the same way in climate science. If you look at CERN, or if you look at ITER, or if you look at the European Molecular Biology Lab, or if the European Southern Observatory, they're all examples of facilities that are established through international cooperation that allows everyone involved to punch way above their weight. And Eve does that for climate science. In the end, it's really pretty simple. The world's changing, and it's changing in ways which we're still relatively blind to, particularly on the scales on which we want to act. And so Eve is really about empowering people with information about the future to inform the decisions that they have to make today. In our mind, at the end of a 2-year preparatory project, we would have a blueprint which we would begin implementing so that at the end of the decade, Eve is up and running in 3 to 5 centers around the world. For this to happen, we have to work together. Eve creates enormous opportunities for everyone. It has the potential to change people's lives. And we invite everyone to be a part of this wonderful and great adventure.